Direct variation occurs when you have a situation where the graph of the line is going to go through the origin and have a constant slope. Okay, so it's always a direct variation function always goes through the origin and has a constant slope. There's going to be a constant represented by the letter K in this equation. That will be, so what's constant mean? Constant means unchanging. So a constant that will represent the relationship between x and y, and it won't change. So it's not like x increased by 1, y increased by 1. Then x increases by 1, y increases by 2. That's not constant. That's a changing relationship. This is a constant relationship. So every time x increases by 1 and y increases by 1, it'll do it again. X increases by 1, y increases by 1. It's going to stay consistent. This is the form that a direct variation function will take. So it'll look like y equals a number times x, like always. That number could be anything. So any constant, any real number, it could be like y equals 2x, y equals 1/2 x, y equals 0.137x. It could be anything. But it's a constant, it's not changing. This is a proportion. You guys have done proportions before. You can only use proportions for things that have a direct variation, which is like everything you did in Algebra 1 and Geometry, but not everything we will do. So we will get to stuff that isn't directly related that way, but that's why we're allowed to use the proportions. The reason like you're allowed to set up a proportion with direct variation is because if you take this equation, you can solve it. See how this says y over x? You can solve it for k. Since k is constant for all ratios y over x, you can take one y over x and another y over x and set them equal to each other because they'll both be equal to k, the constant. So that's why we're allowed to do this, but in other situations, like we'll do inverse variation in the distant future, you can't like set up a proportion like that. So what we're going to do is we're going to see if something's direct variation. They give us some equations. We're basically going to try to manipulate the equations so that they look like this, if possible. And then we'll identify what the constant of variation is. So this is our equation. We want it to look like this. How can we get this to look like this?
Can you divide by 3?
You probably want to divide by 3 because that's what's in front of y. We want y by itself.
Okay.
Now, this says 7x over 3. Can we make that look like 7 over 3 times x? Is that allowed?
Mm-hmm.
Yes, that's allowed.
Then divide by.
Is this direct variation?
Yes.
Yes. So this is a direct variation. If this is direct variation, what's k? 7 over 3. So the constant multiplying by your x, that's your k. I don't know why we spell k with or constant with a k, but that's usually use it all over the place in math. K for constant. We use c for other things, so I guess we're just trying not to get confused with it.
I forgot my notes. Can I just take a picture of it? No, I'm saying I forgot it at home.
You drive back home?
Yeah,
Let's
I'm
try
gonna
the
I'm just
same
gonna drive
kind of
back
method
home.
with the
30
second one.
minutes
So what
back.
can we do here?
Divide
Divide by 7. Remember when you divide by 7, you have to divide everything by 7. Okay, so 7y divided by 7 is y. 14x divided by 7 is 2x. 7 over 7 is 1, not 0.
So is that not a constant or direct?
What's different about this one that
As a +1.
Right. So if it has a +1, is it going to go through the origin?
No.
No. So it's not direct variation. It's still linear, but it's not direct variation. It does still have a constant slope, but it's not that perfect ratio where every y divided by every x is going to be equivalent to a number. Because of that +1's going to screw it up.
So when we're like taking a quiz, right? And we got one of those and we just say not direct variation, do we have to put linear as well with it?
It's going to say determine if it is, and you're going to say like no, and then it says if it is, identify the constant.
Oh, then we
Direct
just write
variation
linear.
is y always equals something times x.
Exactly.
It can't be like 2x plus
Or y over x equals constant.
So it can't be like 2. That's wrong. It can't be like 2x plus 1.
Yeah. Yeah, that one, if we take that away, then it is direct variation.
Okay.
Okay.
Let's look at 2A. So 2A, determine if it's direct variation. Can we try to make this look like this? How do we get y by itself? Here.
Oh
Okay.
my god, I'm really dumb.
So y over
I got on pencil
5
X the
over
whole time.
x.
I thought I
Can
forgot
I
pencil
rewrite
X.
this like this?
Yeah. Wait.
Thank you, bro.
No.
No. This says 5 divided by x. This says 5 times x. These are not the same.
No.
Those are not equivalent. So that means what? This isn't direct variation. This is an example of inverse variation. Okay. Next one says
Oh,
y
times
over
Times
x. So times x.
Yes,
Multiply
that's
by
good.
x. Is this one okay?
Yeah.
Yeah. So if it's direct variation, what's k?
2.
Two.
Yeah. So k is 2. So let's look at, in this one, we're gonna actually use the numbers, we're gonna graph it, and we're gonna create the equation. So they don't give us the equation, that they give us is a relationship. It says that y equals 9 when x equals negative 5. So just so you know, when they're saying that, they're giving you this point, negative 5 comma 9. That's what that means. Y equals 9 when x equals negative 5, they're saying that's a point on the graph. So what we want to do is try to figure out the y equals k times x equation for
It'd
this.
just be like 9 equals negative 5x.
So we're going to start with that. Yeah, we're going to take the y, which is 9, we're going to plug it in for y. We're going to take the negative 5, plug it in for x.
Oh.
We're going to use that to solve for k, constant. So how can we solve for k?
Oh, divided by 1.
Yeah, so divide by negative 5, and we get 9 over negative 5. Now, is 9 over negative 5 equals to k, is that the equation of the function?
No.
No.
No, that's just what k is, so that's good, but it's not the function. Y equals negative 9/5 x is the function that we could graph, or we could substitute values in, like that's what we're looking for.
So K is the slope, basically, in this problem.
So k is the slope. Now it says find y when x is 11. We have a function, we can just plug it in. All we're gonna do, plug in 11 for x, and then like see what you get. Now in this situation, we're not gonna get a very pleasant number.
You get negative 99 over.
Can't really simplify that, so yeah, it's negative 99/5. That's fine,
That's a beautiful number.
beautiful number. You don't need to do anything with it, it doesn't
This is
simplify.
an irrational number?
So like, how do you even graph
No,
that?
irrational,
Oh, it
It's-
actually ends.
yeah, it ends.
It's negative 19.8.
Yeah, so it's rational, can be written as a fraction, then it's rational.
How do you graph?
So let's graph it. So I told you before that every direct variation function goes through the origin. So when you're graphing a direct variation function, you can always graph the origin. The reason for that is because if you make a table of values and you plug in 0 for x, what do you get? You get 0 for y. So the first point you'll graph is 0, 0, because it's like the easiest one to graph.
Or you know, like this.
No, it's just gonna be straight.
It's gonna go
It's
linear.
linear.
Oh, linear, yeah.
Yeah,
it's
it's linear.
linear.
So from here, you can either plug in another x value or you can use the slope. In this graph, this isn't gonna be like big enough. So maybe I wanna scale it, because this is only 1, 2, 3, 4, 5, 6, 7, and my slope is up 9 over 5, right? So maybe I'm gonna go by 2s. 2, 4, 6, 8, 10, 12.
Wouldn't it be down 9? Since it's negative 9?
Aw, yeah. Yes. Or you could go up and to the left.
Oh, yeah.
So I'm just gonna scale by 2s.
Do we have to write if we scale out by 2?
How am I gonna know if it's scaled by 2s if you don't write it?
Can we just write one area?
You could write like 1, you could write like 2. Like, you don't have to necessarily put in all the numbers, you can skip like this. Right, put in a few. Or just a couple, like that. Is that good compromise for them. Yeah, you raise some of these guys really busy. Alright, so from my origin, I got 0, 0. I'm gonna go either up 9, so 9 would be right there in between 8 and 10, and then to the left 5, so 2, 4, 5. That's one way I can go. Or I can go down 9 and to the right 5. 2, 4, 5. So those are your options. Up and to the left or down and to the right. You want it to be a negative slope, so you want it to be decreasing from left to right. A salesperson's commission varies directly with sales. So, some of you might not know what that is. Commission, sales, all that good stuff. So, when you go to like a car dealership and you buy a car for lots of money, you know how like the first thing they do is come up to you and say, hey, you want to buy a car? And they're like really annoying and pestering. That's because they make money off the sales that they have. So, if they sell you a car, that guy's going to make a percentage of that. You see commission also in like Verizon or AT&T, the people that sell you your phone. Like if you've ever purchased a phone from AT&T, whoever sold you that phone made a percentage of that sale. It's like a bonus. Kind of like how waitresses or waiters, they make tips. Like it's like added to their salary. So they still make money hourly, but then if they sell you something, they make a little bit on there. Kind of like realtors, when they sell you a house. They make their money because they get like a certain percentage of the sale. So that's what commission is. If I sell you $1,000 in sales, so maybe I just sold you an iPhone for $1,000. That's a thing, right? That's like how much they are now.
Yeah.
Crazy. He's gonna make $85 in commission. So that's like what he gets to take home. Yay! So obviously there's like an incentive there. So what we want to do is figure out what commission would be for $2,300. There's a couple ways we can do this. So I'm gonna do it 2 ways. One way is like easy way, one way is like the harder way, but you want to know both ways depending on what the question's asking. So the first way, I'm gonna create a function, because when you create a function, you're making something that'll work for all scenarios, right? So maybe I'm just not necessarily curious about this one case, I'm curious about all cases, like what is the, what's that relationship? So what we would do is first we have to figure out which is our independent and which is our dependent variable here. Does the commission depend on the sale, or does the sale depend on the commission?
Commission depends on the sale.
Commission depends on the sale. So that means commission is Y and sales is X, right? That's what that means. I'm changing the variable so that this makes a little bit more sense as we're referring to it. So I'm gonna let commission be my Y, and I'm gonna let S be my X, my independent, my dependent variable. And I'm gonna create a function just like we did for those other questions. So I know this. I'm gonna plug in 1,000 for my, no, I'm not gonna do that, that's dumb. I'm gonna plug in 85 for my commission, and I'm gonna plug in 1,000 for my sales, because that's what it says. $1,000 in sales makes $85 in commission. Then I'm gonna solve for K. So to solve for K, I would probably divide by 1,000. I could simplify this fraction, but since it's like zeros, I'm gonna put it as a decimal because we got that cute little zero trick where we can just move the decimal place over 3 times. So like 1, 2, 3. So that's gonna be 0.085. I also like the decimal in this case because this kind of means something. What's this number as a percentage? 8.5, yeah. So what that means is the salesmen or women, whatever people, the salespeople get 8.5% in commission from their sales. So our function that we'd create would be y equals, or not, I'm going to stick with my c. So c equals 0.085 times s. And I could use that to figure out what they would make in commission for anything, right? The question wants us to figure out what the commission would be for $2,300. So we can just plug in 2,300. You guys can use your fancy new calculators if you want. You gotta just like use it for everything at this point so you get used to it. And then that'll give us the commission for that, but the function would give us the commission for like anything. You're gonna get $195.50 when you sell $2,300 of stuff. So
That's
maybe
so little.
you sold like 2 phones and a bunch of like accessories.
Wait, well, along with the salary?
Yes, usually along with the salary.
That's cool.
Yeah. Okay. Now that's the most in-depth way to do it. That's the way that you can get the whole picture, you can see everything. We can also just make this a proportion. So we can make it a proportion because it's direct variation. And we know it's direct variation because it said this.
Varies
It
directly.
says commission varies directly with sales. That's how we know that it's direct variation. If it says commission varies indirectly with sales, it's inverse variation or something else. Like, we're doing that later, so don't worry. But that's what that means when it varies directly. It means we're talking about a direct variation situation, and so therefore we could just use a proportion. Well, we would take, so we'd take our like 85, we'd put it over 1,000, and then we would take the other commission, we don't know what it is, and we would put it over the other sales, and then we could just cross multiply and solve.
Oh yeah.
We'll get the same thing. It's faster, but it doesn't really give us the whole picture, but it works. Okay, so either one is fine, but if you're asked for a function, which I'm gonna ask you for, then you have to be able to write the function. So you still need to know how to do this process, but to solve the question, you don't really need any of this. You can just go,
I made it. Cause it sounds slow.
right, and then divide by 1,000, you'll get the same answer.